Hello and welcome to 6.6 Notes. Let's start right off the bat with a theorem. Okay, so we have the triangle proportionality theorem, which states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So let's look at this triangle here. We have a line segment TU. That's the line to which this statement above is referring to. It's parallel to one side of a triangle. It's parallel to QS. So this is the side we're talking about. And it intersects the other two sides. It intersects QR and RS. So it meets the stipulations or conditions of the if-then statement. If a line is parallel, yes, it's parallel to one side of a triangle, and it intersects the other two sides, and it does intersect QR and RS, then it divides the two sides proportionally. Okay, and the key word here is proportionally. Okay, it divides them proportionally, not necessarily congruent. That only happens if T is a midpoint of QR and U is a midpoint of SR. If that were the case, then you could say that QT is congruent to, or line segment QT rather, is congruent to line segment TR, and line segment SU is congruent to line segment RU. But that is just a special case. The mid-segment theorem is just a special case of the triangle proportionality theorem and its converse, which we'll get to in a bit. But that's not always necessarily true, just one special case. In other words, you can have line segment T be here, or here, or here, or here, or here, or here. As long this one right here, I kind of did it roughly. It doesn't look parallel, so that one would probably be the exception. But it has to be parallel, and if it's parallel to that third side, then it cuts proportionally. So if TU, line segment TU, is parallel to line segment QS, then RT divided by TQ is going to be the same value as RU divided by US. And you can use that triangle proportionality theorem to find missing links. Okay? Okay, and we have now the converse of the triangle proportionality theorem, which states that if a line does divide two sides of a triangle proportionally, then it must be parallel to the third side. Okay? So in other words, if you have this triangle, for example, and you take RT and divide it by TQ, and then you also take RU and divide it by US, if those two ratios are the same, that will only happen if TU is parallel to QS. So that's the statement you want to write down there. If RT divided by TQ equals RU divided by US, then the only way that can happen is if TU is parallel to QS. Okay? Okay, now let's find the length of line segment YZ. So that's this length here. We don't know what that length is, and it is our task to find out what that length is. But we can use, of course, the triangle proportionality theorem because we have these two chevrons, right? These are called chevrons, and they denote that those two line segments are parallel to each other. So because we see those chevrons, we have that line segment VZ is parallel with line segment WY. Therefore, WX divided by VW is going to be the same as XY divided by YZ, the value that we need to find out. So let's plug those numbers in and see what we get. Okay, so we have 44 divided by 35 is equal to 36 divided by X, and then we cross multiply and get that 44X is equal to 36 times 35. So now you bring down the 44x. Remember, if you don't do something to a value or a side of the equation, you bring it down. So we bring down 44x, and that's equal to 1,260. 36 times 35 is 1,260. So 44x is equal to 1260. We divide both sides by 44 and get that x is equal to 315 elevenths. Okay, that's a perfectly acceptable number. It's a fraction that's reduced to lowest terms. 315 elevenths. We're good. 315 elevenths, or as a decimal, you can call it 28.63 repeating. So that value is 28.63 repeating, or 315 elevenths. Okay? Okay, now let's determine whether line segment PS is parallel to line segment QR. And because of the triangle proportionality theorem, if PQ divided by NP is equal to RS divided by NS, then yes, those two line segments will be parallel. So if PQ divided by NP is the same as RS divided by NS, then that must mean that PS is parallel to QR. That can only happen if those two line segments are parallel to each other. Okay, so let's plug those values in, and let's try to verify if that's true or not. So verify, is 50 divided by 90 the same as 40 divided by 72? Remember, PQ is 50, NP is 90, RS is 40, and NS is 72. So that's just plugging in those values and coming up with this proportion. And if those two ratios are equal to each other, then PS must be parallel to QR. There's no other way for that to happen unless they're both parallel, right? Because of the triangle proportionality theorem. So what I'm going to do is divide by 1, right? I'm taking 50 divided by 90, or 50 over 90, I should say, and I'm dividing by my magic number 1. My magic number 1 in this case is 10 over 10, because 10 is the greatest common factor that can go into 50 and 90. Okay, but remember, I'm still dividing by 1, and any number divided by 1 is still that number, right? So 10 divided by 1 is still 10, 25 divided by 1 is still 25, 99 divided by 1 is still 99. Anything divided by 1 is still itself. So 50 divided by 90, or 50 over 90 rather, divided by this magic number 1 is still going to be 50 over 90. And similarly, 40 divided by 72, or 40 over 72, I'm dividing by my magic number 1, which in this case is 8 over 8, because 8 is the greatest common factor that can go into both 40 and 72. And yet again, I'm dividing by my magic number 1, so the value is going to stay the same. So 50 divided by 90, or 50 over 90, or 50 90ths, divided by 1 is still going to be 50 90ths. 40 70-seconds divided by 1 is still going to be 40 70-seconds, but I've reduced them, right? So 50 90ths reduces to 5/9, it's the same value, and 40 70-seconds divided by 1, divided by 8 over 8, is 5/9, it's still the same value. But you need to do that so that you can compare the two ratios. It's sort of hard to see that 50 90ths is the same as 40 over 72, but it's not hard to see that 5 over 9 is the same as 5 over 9, right? So we do see, that's why I have this check mark here, we do see that they are in fact the same. So that can only happen if these two line segments are parallel to each other. Okay? So therefore, line segment PS is parallel with line segment QR. All right, we have another concept here. This is another theorem. It states that if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So here are our 3 parallel lines, right? Those are the chevrons. And these are our 2 transversals. They divide those transversals proportionally. So that means this divided by this is going to be the same as that divided by that. Again, it does not mean that they're congruent. Okay, we're not saying that UW is congruent with VX or that UW is congruent with WY, or any congruent. This is not a congruency statement. This is a proportionality statement, saying if we take this number and divide it by this number, we're going to get a certain value, and that's going to equal this divided by that. Okay, they'll be in proportion to each other. Okay, and we can use these facts again to find missing side lengths that we don't know. Okay, we'll do that in a bit. Then there's another concept, okay, another theorem. It states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. That sounds really complex, but I think if you look at this little diagram, it should make sense to you. Okay, so we have a ray. This is a ray, and it's bisecting angle ACB. And so it's bisecting this angle. We have the tick marks, right, showing that they're congruent. And so AD, this length, divided by DB, which is this length, is going to be the same as CA divided by CB. Okay? Well, alrighty then. Now our task is to find the length of line segment AB. And again, of course, at any time during this presentation, if you need to pause it, to write down this figure or anything like that, of course, always feel perfectly free to just, pause this presentation or, rewind and go over things again. I mean, that's perfectly acceptable, and also that's being a wise student, right? That's taking your learning into your own hands. But anyway, find the length of line segment AB, and so this is the line segment right here that we need to find. We don't know what that is, and it's our task to find what that is. Well, we do have three parallel lines that are cutting through two transversals, correct? So that means that we've divided those transversals proportionally. That means 16 divided by this value is going to be the same as 15 divided by 18. Okay, so let's plug those in and see what we get. Okay, we have 16 divided by x is equal to 15 divided by 18, and we can cross multiply and get that 15x is equal to 18 times 6. So 15x is equal to 288. We divide both sides by 15 and get that x is equal to 19.2. Okay? So this is our last problem, and our task is again to find the length of line segment AB. And we do have a ray that's bisecting an angle of a triangle. And so then it must be dividing the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So in this case, it's CD divided by BD must be the same as AC divided by AB. AB being the side length that we want to know. Alright, so let's plug in some values and see what we get. So we have 4 divided by 4 is equal to 4 root 2 over x. And you know what? We could cross multiply at this point, but I'm noticing that 4 over 4 is actually the same as 1 over 1, right? You just divide both the numerator and denominator by 4, and you get 1 over 1. So I'm going to write 1 over 1 is equal to 4 root 2 over x. And now we can cross multiply if we want to. Okay, we can still cross multiply. But I think we can kind of do a little shortcut, right? If we have the ratio 1 over 1, that's basically saying same over same. And so I think it stands to reason that that can only be true if x is 4 root 2. So I think we can just kind of bypass the cross multiplying and just simply state that x is equal to 4 root 2. So this value then is equal to 4 root 2. Okay, so that's the end of the lecture. If you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you out. Okay, bye-bye.